I want you to imagine, just for a second, that you are walking down like this incredibly chaotic, loud city sidewalk.
Oh, yeah. People just bumping into your shoulders everywhere.
Exactly. Cars are honking. You're probably looking down at your phone, just trying to get where you need to go. And suddenly, a total stranger steps right into your path.
Which is always a little jarring.
Right. And they just reach out and hand you a crisp $20 bill. And they tell you, there's only one rule for this money. You have to spend it by midnight.
Okay, I like this scenario.
So what do you do with it? I mean, if you're like most people, your immediate intuition tells you that taking that 20 bucks and, treating yourself to a fancy coffee or maybe a new paperback book is going to bring you the maximum amount of personal bliss. But is that actually true?
Well, it's kind of the ultimate question, isn't it? I mean, we walk around all day with these built-in, completely untested assumptions about what makes us happy or, what makes us stressed or even just how our own minds work.
Yeah, we just assume we know.
Right. But human intuition is actually famously unreliable. We think we know what drives our behavior, but our internal logic is, well, it's heavily biased.
Which is exactly why we're going on a specific mission for today's deep dive. We're exploring how we actually know what we know about human behavior. We're looking at research designs, basically these strategic architectural frameworks that scientists use to, systematically answer empirical questions about who we are.
And it is so important right now.
It really is. And we have a fantastic stack of source material guiding us today. We're pulling insights from the Discovering Psychology 2.0 curriculum, some structural frameworks from author Christie Napa Scollon, and some really fascinating data from the Diner Education Fund.
Yeah, plus those really eye-opening case studies and current events from year 2026.
Exactly. Because, we live in a world where we are constantly bombarded by information overload.
Oh, completely. And in that kind of world, understanding how a study is designed is, I'd argue, just as important as the flashy headline it ends up generating.
Yeah, because the headline is usually misleading.
Right. If you don't know the architecture of the research, you don't know if you can actually trust the result.
So let's start with the absolute foundation here. Because before we can unpack something as complex as human happiness or why that $20 bill behaves the way it does in our brains, we have to understand the difference between just watching the world and actively changing it.
Right, because in psychological investigation, there are basically two primary structural pillars. You have correlational designs and experimental designs.
Okay.
And they are fundamentally different approaches to looking at reality. So in a correlational framework, a scientist is just passively monitoring variables as they naturally manifest.
So they aren't intervening at all.
Exactly. No intervention. You are simply mapping out the interconnected landscape of everyday behavior to see, what naturally goes together.
Okay, so let's unpack this a bit. A correlational design is essentially like noticing that people carrying umbrellas are very often walking in the rain.
That's a great way to put it.
You see the association. But an experimental design would be like going up to someone, taking their umbrella away, and seeing if that specific action causes them to get wet.
Precisely. You're isolating the variable. An experimental framework requires the investigator to actively introduce, systematic modifications to what we call an independent variable.
Okay, so you're tweaking something on purpose.
Yes. You manipulate one specific thing in the environment to establish a definitive cause and effect relationship.
And I feel like this brings us right back to that $20 bill.
Yeah.
Because that wasn't just a hypothetical scenario, right? That was an actual groundbreaking study conducted back in March 2008 by Professor Elizabeth Dunn.
It was. She wanted to really test our assumptions about financial wealth and joy.
Right. And if she had just observed people who naturally spend money on themselves versus people who, naturally donate to charity, which would be a correlational approach.
She wouldn't actually know why they were happy.
Exactly.
Because, generous people might just naturally have happier dispositions anyway, totally regardless of the money.
So she intervened. She actually forced random groups into different behaviors. Like, she forced one group to spend the money on themselves, and she forced the other group to spend it on someone else.
And by enforcing that behavior, the vivid contrast in the results proved that generosity isn't just loosely associated with happiness.
It causes it.
Right. It is a direct causal catalyst for well-being. The people who were forced to spend on others reported significantly higher levels of happiness.
Which is crazy to think about.
Exactly. So to actually find the truth, a university ran an experiment where they randomly restricted screen time for selected freshmen.
They took the umbrella away.
They took the umbrella away, and they saw a direct causal drop in physiological stress markers. So observational tracking gave them the clue, but it had to be paired with structured intervention to actually help those struggling learners.
Man, that reminds me of that William James quote from our sources. He said, "The separation of psychology from premise-free philosophy was achieved only when we began measuring life."
That's a perfect quote for this. I mean, philosophy asks what happiness is, but psychology actually measures the physiological drop in stress when you put your phone away.
Right. Wait, I have a fundamental question about this.
Sure.
If correlational studies are just noticing the umbrellas,
Yeah.
and they can't actually prove causality, like they can't prove why the anxiety is happening, why do scientists even bother with them? Why not just run these hard-hitting experiments all the time?
Well, because you can't always run an experiment. I mean, sometimes it is ethically impossible or just practically absurd to manipulate a variable.
Oh, I see. Like, I suppose you can't force a group of healthy people to smoke 2 packs a day for 20 years just to definitively prove that it causes lung cancer.
You absolutely cannot do that. That would be completely unethical.
Right, yeah.
So we have to rely on the math of human connection. While correlations don't prove the why, they are essential for revealing the hidden mathematical and statistical relationships that govern our everyday lives.
Okay, so how do we actually read that math?
Well, interpreting these correlations comes down to evaluating two mathematical properties: direction and strength.
So if the math shows us a direction, what does that actually look like in real life?
It looks like a scale from -1 to +1. So a positive correlation means the variables rise and fall together.
Yeah.
Think of like studying and test scores. As the hours you study rise, your grades predictably rise in synchronized steps.
That makes sense. And a negative correlation.
As one variable rises, the other predictably plummets. So the more hours you spend scrolling on your phone in bed, the less sleep you get.
But our sources emphasize a really crucial caveat here, right? Because these correlations describe broad patterns, they are not absolute individual certainties.
Oh, absolutely not.
If you have a weak statistical correlation,
Yeah.
you are going to see numerous exceptions out in the real world. Like, everyone knows that one person who never studies and aces the exam.
Or the person who drinks a triple espresso at midnight and just sleeps like a baby.
Yes,
Yeah.
exactly. Individual human experiences constantly deviate from the broader statistical trend.
But, those deviations don't make the math useless. H.G. Wells actually once said, statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write.
Wow.
And what's fascinating here is why identifying these broad patterns matters so much at a systemic level. Like, look at another 2026 report from our sources. It revealed a strong positive correlation between part-time work, specifically working over 20 hours a week, and academic burnout among second-year non-traditional students. And that burnout negatively correlated with their GPAs.
So the math gave a really clear warning sign. High work hours point to high burnout, which then points to failing grades.
Exactly. And understanding those statistical directions allows academic advisors to build proactive support systems. They can intervene and safeguard student mental health before a student actually fails a class.
That's huge.
Right. They don't need to prove that the job caused the failing grade. They just need to know the pattern exists so they can step in.
So what does this all mean for you listening? I mean, take a second to look at your own busy weekly schedule. What habits seem to rise and fall together?
That's a great exercise.
Maybe when your work hours go up, your fast food consumption positively correlates right along with it. Or maybe when your daily step count goes up, your baseline anxiety goes down. Recognizing those mathematical patterns in your own life is the very first step to changing them.
Very true. But when you actually want to guarantee that changing a habit will cause a specific outcome, when you really want to prove it, we have to move from the passive math of correlations back to the active manipulation of experiments.
And here's where it gets really interesting. Because the holy grail of psychological research is forcing the issue to prove causality. Causality is the directional relationship where one event directly generates the occurrence of another. It's the definitive cause and effect. But how do researchers actually pull that off? Because human beings are messy.
Very messy.
How do you prove that one single thing caused my happiness and not the fact that, I don't know, I just had a really good cup of coffee that morning?
Well, it requires a remarkably rigorous mechanical setup. And it all hinges on one single concept: random assignment.
Okay, so how does that actually work in practice, like out in the field?
Let's say you have 1,000 participants. If you just ask for volunteers to try a new study technique, all the highly motivated, overachieving students might rush to volunteer for that specific group.
Oh, which ruins the test. Because you wouldn't be measuring the study technique, you'd be measuring their natural motivation.
Precisely. You've skewed the data before you even started. So instead, you use random assignment. You basically flip a coin for every single participant.
Yeah.
And the sheer mathematical probability dictates that the lazy people, the anxious people, the naturally brilliant people, and the sleep-deprived people will be perfectly and evenly mixed into both groups. The coin flip basically cancels out human unpredictability.
I see. It distributes all those quirky individual baseline traits equally.
Exactly. Then, and only then, the researcher manipulates the independent variable while holding absolutely every other external environmental factor completely constant.
Every single one.
As much as humanly possible. They control the room temperature, the time of day, the specific instructions given. This rigorous control eliminates what we call confounding variables.
Those sneaky alternative explanations, like the good cup of coffee.
Right. By eliminating the coffee, the room temperature, and balancing the baseline motivation, researchers can confidently attribute any changes they see in the dependent variable directly to the manipulation they introduced.
Our sources actually highlight a clinical trial from May 2026 that illustrates this perfectly. Researchers wanted to know if brief mandatory mindfulness apps actually work for first-year community college students dealing with test anxiety.
Oh, yeah, this is a great example.
So they took a large group of non-traditional learners, used random assignment to mix them up, and gave half an active mindfulness app and half a passive placebo app. And by keeping everything else in the testing environment constant, they isolated the app itself. They proved it causally reduced anxiety.
And the rigor of that isolation is what makes it science. Albert Einstein actually had a brilliant quote about this. He said, "No amount of experimentation can ever prove me right. A single experiment can prove me wrong."
Wow.
Yeah, experiments are fundamentally designed to eliminate every other possibility until only the truth survives the test.
Think about how you would apply this to your own friend group. If you wanted to run a true experiment to prove that a new morning routine actually causes happiness, you have to flip a coin, force half your friends to do it, force the other half to do a placebo routine, and somehow control everything else they eat, do, and experience for the entire week.
Which really highlights the immense logistical nightmare of running a true experiment on human beings.
Yeah, that sounds impossible.
Mm-hmm.
So if we know we need random assignment and lockdown environments to prove causality, but you want to study the behaviors of thousands of people across the country, you obviously can't physically lock them all in a lab.
No, definitely not.
So how do researchers gather that massive amount of deeply personal data out in the real world?
Well, they have to ask. And they rely on the workhorses of psychology, which are surveys and timelines.
Yeah.
Surveys are incredibly versatile tools for gathering self-reported data from massive representative samples.
Right.
You can have 10,000 people fill out questionnaires about their deepest desires, their daily spending, or, their emotional states.
And in correlational research, you use those surveys to map out multiple variables at once. But our sources warn about a huge danger here. People lie.
They do. They really do. The biggest threat to survey data is participant bias.
Right.
People inherently want to look good, even on a completely anonymous questionnaire. If you ask someone how much alcohol they drink a week, they will almost always underreport it.
I mean, naturally. But beyond people just lying, the researchers themselves can mess it up with leading language, right?
Oh, absolutely. The way you phrase a question can inadvertently skew the data entirely. If a survey asks, "How frustrated are you with the terrible parking on campus?" The word terrible is leading you to be frustrated.
It implants an assumption before you even answer. There's a great quote from Orson Scott Card in the materials that says, "The truth is, Miro, people don't know what they think until you ask them."
That's so true.
But the very act of asking shapes the thought itself.
It's a really delicate balance. But, when constructed neutrally, surveys are powerful. In August 2026, a nationwide survey went out to measure virtual tutoring satisfaction among working adult learners. And the universities gathered all this fast, self-reported data, but they didn't just stop there. They actually used the survey patterns to design a controlled experiment testing specific AI feedback systems.
Oh, that's smart.
Yeah, the survey pointed them to the structural problem, and the experiment tested the causal solution.
So that's the fast way to get data. Just blast out a digital questionnaire. But our materials also detail the incredibly slow way, the dramatic journey of the longitudinal study.
Yes, and this is a completely different scale of time. In a longitudinal design, researchers track the exact same group of participants repeatedly over an extended period. We are talking years, sometimes decades.
But why go through all that trouble? I mean, why not just survey a bunch of 20-year-olds and a bunch of 80-year-olds today and compare them?
Because of what we call cohort effects or generational effects.
Okay, what does that mean?
Well, if you compare a 20-year-old and an 80-year-old today, you aren't just measuring the biological difference in brain aging. You are measuring the fact that the 20-year-old grew up with iPads and social media, and the 80-year-old grew up with rotary phones and radio.
Oh, right. The culture contaminates the data.
Exactly. So a longitudinal study eliminates that culture clash by watching the slow, elegant unfolding of human aging in the exact same person.
That reminds me of the Anais Nin quote from the sources.
Yeah.
We do not grow absolute chronological age. We grow riper, more complex creatures.
It really captures the nuance perfectly. And a current event from 2026 showcases this. There was a 5-year tracking program monitoring non-traditional first-year college students.
Okay.
And by tracking the exact same individuals over half a decade, they found early definitive signs that consistent peer mentoring strongly predicts long-term graduation success across all age brackets.
Wait, so a researcher might dedicate 10, 20, or even 30 years of their entire career to a single study, knowing they might literally retire before the final data is even published?
It happens all the time. It is a stunning commitment to the scientific method. But the downsides are brutal.
I can imagine.
Yeah, it requires immense financial resources, tremendous patience, and the harsh reality of participant attrition. Over 30 years, people move away, they drop out of the study, or they pass away.
The patience required is just staggering, which honestly brings us to a really uncomfortable realization.
What's that?
Well, we've just walked through all these tools, and every single one of them has a major flaw. I mean, surveys suffer from participant biases and leading questions. Longitudinal studies lose participants to attrition. Correlational math can't prove causality. And highly controlled experiments are locked in these artificial environments.
Yeah.
So if everything is flawed, how do we trust any scientific breakthrough?
It comes down to what we call the researcher's dilemma. Conducting psychology is essentially the art of strategic compromise. Every scientific research design possesses distinct strengths and inherent weaknesses.
Right.
Take a laboratory setting. A lab gives you absolute control over cause and effect, which provides high internal validity. You know exactly what caused what.
But no one acts completely natural in a sterile lab with, like, electrodes on their head. The setting is artificial, so it has low ecological validity. Doesn't look like the real world.
Exactly. But if you swing the other way and do real-world tracking, like naturalistic observation, you capture highly authentic behavior, but you absolutely cannot rule out all those confounding variables we talked about. There is no single perfect method.
And our sources also mention quasi-experiments as a kind of middle ground. What exactly is a quasi-experiment?
So a quasi-experiment is when researchers compare existing groups based on a specific variable, but they don't use random assignment.
Okay, so like comparing a college class taught by a human teacher versus a class taught by an AI program.
Yes, but the key is that the students picked which class they wanted to take. You get real-world data, but because highly motivated tech-savvy students might naturally choose the AI class, you lose your random assignment.
Oh, I see.
The motivation becomes a confounding variable. You aren't purely measuring the AI anymore. You are measuring the types of students who choose AI.
So the lack of a coin flip basically limits how firmly you can claim causality.
Right. Which is why the ultimate solution to the researcher's dilemma is the multi-method approach. It's about compensating for the limitations of any single design by layering them together.
Layering them.
Yeah, in October 2026, university researchers were fiercely debating how to study student attention spans during hybrid lectures.
Right, because half the researchers probably wanted pristine lab experiments, and the other half wanted messy, naturalistic observation in real classrooms.
And ultimately, they realized they had to combine both. They used the lab to isolate the precise neurological impact of digital distractions, securing their internal validity. Then they used real-world classroom tracking to capture the authentic experiences of non-traditional working students, securing their ecological validity.
Wow.
And by layering them, they were able to accurately and confidently redesign those introductory courses.
Yeah. It makes me think of the famous quote by statistician George E. Peabox. He said, "All models are wrong, but some are useful." But I have to push back on that for a second.
Sure, go ahead.
If a brilliant statistician openly admits that all models are wrong, doesn't that just give people a really convenient excuse to ignore any science they happen to disagree with? Like, oh, well, the model's wrong anyway, so I don't have to believe this finding about climate change or public health or human behavior.
Yeah, it's a trap a lot of people fall into. But when Bach says wrong, he does not mean false or fictional. He means incomplete.
Okay.
Think of a physical map of a city. A map is technically wrong because it doesn't show every single pothole, traffic light, and blade of grass. It is a simplification of reality, but it is still incredibly useful for navigating from point A to point B.
So the map isn't a lie, it's just focused.
Exactly. Spotting the hidden limitations of a study, whether it's a lack of ecological validity in a lab or a confounding variable in a quasi-experiment, it isn't about discarding the science entirely. It's about being an educated consumer of information. It's about knowing the exact boundaries of what the study can and cannot tell us.
It's not about finding a reason to reject the data, it's about understanding its context. And honestly, that brings our journey today into really clear focus. I mean, we started on that chaotic sidewalk with the $20 bill experiment, proving that actively intervening, like forcing a behavior, can definitively show us that generosity causes joy.
Yes.
And then we explored the passive math of human connection, how positive and negative correlations map out our habits and warn us about burnout, even if they can't tell us why.
We also broke down the immense mechanical rigor required to establish causality through random assignment and controlled experiments.
And we dug into the tools of the trade, the massive reach of surveys and the dangers of leading questions, the profound patience required to track human aging and longitudinal study. And finally, the reality that every method requires a strategic compromise. The big takeaway here is that critical thinking is absolutely essential. We live in a world where we are constantly scrolling past flashy headlines claiming science proves X. But now you know the structural scaffolding behind those claims. You know how the sausage is made.
And as we wrap up, I want to leave you with a final, slightly philosophical thought to mull over.
Okay, let's hear it.
We've spent this time talking about observing behavior and setting up rigorously controlled environments to find the truth. But think about your own life. If you decide to apply this, and you try to test your own daily habits to find a causal link to your own happiness, does the very act of observing yourself ruin the experiment?
Oh, wow.
Can we ever truly be objective when we are simultaneously the researcher running the test and the subject being studied?
That is a serious head-scratcher to leave off on. Are we contaminating our own data just by looking at it? Well, thank you so much for joining us on this deep dive into research designs. Next time you see a bold news headline making a claim about human behavior, remember to look past the result and question the methodology. Until next time, keep questioning, keep learning, and spend that metaphorical $20 wisely.